just come to the, we have finished the unit 2.1. We just come to the unit 1.1, very basic concepts in computing. In here we just look at what is data and life cycle of the data and the comparisons between the data and the information and the golden rule for the information. Then we come to the big data analytics will be discussed. So basically, what is data? So data means maybe collection of numbers, characters, images, videos, animations, like together we call as a data. So the data is not processed actually. Normally we cannot take any decisions with the data. So this data is represented in the computer always in binary 1-0 patterns. Now as an example, once you complete your term test in your school, now teacher can collect all the marks together and she can store them in a table. So then that's just a data. Once the term tests are over, all the data can be stored, all the marks can be stored in a kind of Excel sheet. So which is just a data. Normally we cannot make any decision with the data. So whenever you are given any statements, if they ask whether this is a data or this is information, how do you decide? It is decided based on the way whether you can make a decisions. Normally with the data it is difficult to make decisions. Decision making always done with the information. So whenever you are given statements, you need to check whether with that statement whether you can make a decision. If you can make a decision, that's a information. That's the data. So these are some of the characteristics or properties of the data. So data can be collected, can be processed, can be communicated, can be saved, and always it is meaningless, and again you can't make a decision with the data. So those are some of the characteristics of the data. So the life cycle of the data, so that is initially we need to create some data. We need to create some data. We need to use some mechanisms to create the data. And once you create the data, once you done it, you have to manage it. For that you have to make some access controlling. So some access must be provided for the data. Then only others can use it. And again, finally, there can be some data which is not accurate, or some of them are obsolete data. So that must be deleted. So that's a basic life cycle of the data. First you have to create the data, and you have to manage this data, and you have to remove some unwanted or unclear or some of the inaccurate data should be deleted. So this is what I explained in the previous lesson actually. That is in current research works we have that issue I told you, quantitative and the qualitative data. When you take the data, some data is quantitative data where you can represent things by numbers. You can express the things by numbers, which equal as a quantitative data. But qualitative data means the data which cannot be represented by numbers. You can't represent by numerical values. Now as an example, quantitative data, you can say length, weight, height, temperature, like those things you can represent by numbers. The things which can be represented by numbers, you can say quantitative data. That can be represented in the computer very easily, because computer needs everything by numbers in binary format. As I told you, people are doing more research on to represent the qualitative data, which cannot be represented by numbers. As I told you, when I say one student is very good, how can you represent that in the computer? because you can't say how much good. What is the number you can assign for the good? What's the number you can assign for the bad? What's the number you can assign for the pretty or handsome? Can you give represent them by numbers? No, you can't give by numbers. That's the issue with the qualitative data. That's the problem people are trying to solve. As an example, as I mentioned earlier, that robotics application, if there's a robot, if you can just say, okay, go to 1 meter forward, he know exactly, he can move exactly 1 meter forward. But if there's a robot, if you just say, okay, come closer to me, he doesn't know what is mean by the closer. If you just say, okay, go near to the table, if it is a human, if you say, okay, go near to the table, he knows how much closer he should go near to the table. But if there's a robot, if you just say, okay, go near to the table, he doesn't know what is mean by the near. It is comparatively changing environment to environment. What is mean by the near? So then those are some problems people are trying to solve in this AI that is coming in this qualitative data actually. Then we'll come to the information. What's information? When the data is processed. When the data is processed, we get the information. With the information, you can always make decisions. As I explained initially, when your term tests are completed, the school teacher has all the term test marks in the tabular form, which is just a data. But after that, she can use some kind of mathematical equations to process it. After process, she can find out who has the highest marks, who has the lowest marks, what is the pass rate, what's the ranking. Everything can be calculated. So once you've done it, the teacher can make a decision. So initially we have the marks like this, it's just the data. Once the teacher is processed, you can get the average marks, highest marks, lowest mark, like those are coming. So with that, teacher can make a decision. If the average marks is, let's say, 95, then teacher knows that his students are very good. She can make a decision. If the average marks are, let's say 35, then she knows that there's a problem, these students are not good. She can make a decision. So remember, with the information, always you can make a decision, not like data. So the information has different properties. Always the information should be relevant. And it should be accurate, very important, accuracy. And information, always we need to get complete information, not the part of the information. And timely availability is a very important factor in the information. We need to get the information on time. Because as you know, when this tsunami in 2004, we did not get that information on time. Some people knew that this is going to be happen, but we did not get that information on time. Because of that, large number of people were died. We could have saved all this life if you receive that information on time. And again, once you receive that information, it should be understandable format. If you receive some information which is not in the understandable format, that is also not useful. And again, cost effective. If it is very expensive, again, people will not use. And again, information should be reliable. Like these are some of the properties of the information. Then where are we using this information? Mainly for decision making. As I told you, when the school teacher gets that pass rate as, let's say, average marks as 35%, then she can make a decision. And based on that, she can make a policy. Now this marks are 35, average marks are 35 means students are bad. Then teacher can make a policy. The student has to do this kind of work or stay this much of time after the school, like policy can be added. In addition to that, we can make predictions. Using these mathematical models. By analyzing this data, we can make a prediction if the 2022 what would happen, and based on that prediction you can make a planning, and scheduling and the monitoring can be done. So like these things can be done with the information. Then this is again one of the very important rule. You can see most of the past papers, this question was there from this diagram. This is very important rule, golden rule for the information, very simple rule. What rule says? It says that with the time value of the information is decreasing. With the time value of the information is decreasing. So lot of questions can be given from this diagram. You will see some past paper questions. So as you know, it's very obvious, when the time goes, the value is decreasing. As an example, when the Sri Lankan team won this World Cup match, all the people were discussing about that. But now, no one can remember about that winning match. So what happened after time goes, values decreasing. That's a very simple rule, but very useful rule. So just remember, always with the timing, the value is decreasing. Okay, now we just come to the current technology, going to this big data analytics. What do you mean by big data analytics? What is big data? So big data means the data which cannot be processed by our computers because of the volume is too large. As you know, with different because this is internet, through the internet, people are adding large number of data, especially through the social media and using other tools. So some billions of large amount of data will be added. When you take the Facebook, you can see people adding the images, audio and a video, and again other characters you type. So it gets some large amount of data will be added to them. If it is the Twitter, people are adding a lot of things to data to that. So then very frequently data will be added. So this data is a very large amount of data which cannot be processed by the normal computers actually. So that's the idea behind the big data. It's a large volume of data actually. So then we need to process this data, or we have to analyze this data. That is we call the big data analytics. So by analyzing that, you can make a lot of predictions and you can get a lot more information from that. So different technologies are using for that. We'll see later, like what we call as this Hadoop is one technology we are using to distribute this workload among the different computers. So basically big data means large amount of data which cannot be processed by our general purpose computers. The amount of data is too large.